Hello, this is AQA A-Level Chemistry. We are on the bonding topic from Year 12 and this is video 9 in a series of 10 for this topic. In the last video we looked at different crystal types, so we had ionic, molecular and metallic, but we didn't see anything about giant covalent structures, and this video is going to be a summary and a reminder of some of the key properties and reasons for those properties for giant covalent. As always, there's a series of questions. I'm going to recommend that you pause as you go, try and answer these for yourself and see how it goes. If it goes well, fantastic. If you're not getting the answers right, it means you then need to do some work to try to develop it and maybe ask for some help on that. So let's begin. Have a think about these questions. And this is generally about giant covalent compounds. So what holds together a giant covalent compound? Well, it's covalent bonds, and there are lots of them. And will their melting and boiling point be high or low? So for giant covalent compounds, you think about some of the key examples, and we're going to look at those later. The boiling and melting points are high. And why is that the case? Well, it's because there are lots of strong covalent bonds, and therefore lots of energy is needed to overcome them. So now let's focus on diamond, one of the key giant covalent structures that we learn about. Have a go at these questions. And this also fits in quite nicely with the shapes of molecule work that came up earlier within this topic. So how many carbons is each carbon bonded to? Now you must remember that this is only a tiny fragment of a diamond. It goes, it's billions, trillions, quadrillions of times bigger than this. But each carbon is bonded to 4 other carbons. Now from our shapes of molecules knowledge, we know that that now means a bond angle will be 109.5, and we know that diamond has a tetrahedral structure. Will it have a high or a low melting point, and why? Well, it will be high because there are lots of strong covalent bonds, so lots of energy needed to overcome them. It's the same answer as the general answer that we just spoke about. Will diamond be hard or soft, and why? Well, we hopefully recognise and remember that diamond is hard. Can we explain why? Well, again, it's about having that huge number of strong covalent bonds. And if I wanted to break a diamond apart, I've got to break a huge number of those strong covalent bonds. So now let's go to graphite, try and answer these questions. And in graphite, each carbon is bonded to 3 other carbons. Once again, we take our knowledge of shapes of molecules. That allows us to see the bond angle will be 120, and the structure, the shape of a graphite molecule within each layer is trigonal planar. So what has happened to the 4th electron in each case? Well, the 4th electron in graphite gets delocalized, and that means because we have delocalized electrons that it can conduct electricity, because those delocalized electrons can carry charge through the structure. Will it have a high or a low melting point, and why? Well, it will still have a high melting point. It might be slightly lower than diamond because there are less covalent bonds to break, but there are lots of strong covalent bonds, so lots of energy is needed to overcome them. And finally, graphite is slippery. Why is that the case? Now you remember that graphite is what we use in what we commonly call the lead in pencils, where layers are broken off and left behind on the paper when you rub it across there. How is that possible? Well, the weak intermolecular forces, the forces between the layers, can be easily overcome. So the layers can slide over each other. Finally, we're going to look at some other allotropes of carbon. Got a question at the top here for you to try. You can actually see that a nanotube is a single layer of graphite that has been turned into a tube. Now, one of the key properties there is that it will be a very good conductor of electricity because of its delocalized electrons. I've also mentioned a little bit here about Buckminster Fuller, the architect. If you want to see why this architect was maybe the inspiration for the name of it, have a look at the Epcot Centre at Disney, which was a design by Buckminster Fuller. Okay, that takes us to the end of this video. Thank you for listening. Goodbye.